Hello students, due to some sorts of eyesight problem, I could not able to take any classes since last 8 months. Within this period, I have gone twice the eye operations. Now I became okay. So I am thinking to start again our classes, and so that my students will be very happy with my videos. Okay. Today I have chosen one topic from second year, that means 12th class. I have already made it in Odia. You've gone through that one. Now we will discuss on English for your betterment of the examination. Okay. Today I have choose one chapter, that is capacitors. Capacitors or capacitance. What is capacity? Capacity means if we are considering about a glass, how much of water can be filled in it? That is the capacity of the glass. Let it contains 200 ml or 300 ml. If we put some more water to the glass, that means that either that water come out of the glass or that will not content in that glass. So before going to discuss about this capacity, first of you choose some instrument and think about its capacity. Okay, we are thinking of a bottle, water bottle. We know it contains 1 liter of water. That means if we put some more water into it, it cannot be added to that one. Either that water come out of it or that may not be filled into it. Okay, let it go. Now we are thinking about the electricity, because our importance is electricity. So before discussing about this capacitors, first of all we have to think the potential difference. As you know, the symbol is V, that is potential difference. Potential difference. Okay, and Q the charge. Q the charge. Charge flowing. Okay. If we are maintaining the potential difference inside a conductor or any two wires, then the amount of charge flowing through it is generally known as the amount of current. Okay, so the flow of current, that means it depends upon the V. So potential difference and charge, they are directly proportional. That means Q always proportional to V. Okay, Q proportional to V. That means Q, that means flow of charge is depending upon the potential difference. That means if we are taking it out, the proportionality, then we have to add one proportionality constant, let that is C, that is C into V. So Q is equal to C into V, or here C is known as the proportionality constant or the capacitance. So C is equal to Q by V. Okay, the unit of this C is farad. Farad. Let we are thinking 1 farad is equal to charge 1 coulomb by 1 volt. Okay, remember Q proportional to V, that means the charge flowing through that conductor is proportional to the potential difference across the two ends of the conductor, and that Q is equal to C into V, or C is equal to Q by V, where Q is the charge, V is the potential difference, and C is the capacitance of the capacitor, and generally its unit is 1 farad is equal to 1 coulomb by 1 volt. Okay, remember this formula, it will be utilized in parallel connection and series connection. This is all about your capacitance. Now we will go to the parallel connection and series connection, when the capacitors are in parallel and when the capacitors are in series. Now we will discuss when the capacitors are in parallel connection. I have made the diagram to minimize the time. Okay, now capacitors in parallel. Okay, when the capacitors are in parallel, we have to find out the net capacitance if there are n number of capacitors. Here we have joined one capacitor, that is C1, another capacitor, that is C2, another capacitor, that is C3, another capacitor, that is up to Cn. That means these capacitors are in parallel. how we can say this is in parallel? If one end of all the capacitors are connected at one point and another end is another point. That means here all the P side plates are connected at the point A and another side, that means Q side, connected at the point B. Then this is called a parallel connection. Okay. Now this is in parallel connection and the potential difference we have maintained V. Okay. The amount of charge flowing through the circuit is Q. That means the Q amount of charge is flowing through this circuit. Okay. As we know, that is V is equal to Q by C, or Q is equal to C into V, where C is the capacitance or the capacitor and Q is the charge, V is the potential. Okay. Here, as the amount of charge is flowing through its Q, it is divided here in different parts. That means the number of capacitors or capacitors are used is here N. So the charge are divided in Q1, Q2, Q3 and Qn in different capacitors. So if we are thinking about this one, then okay, I have written it as we have discussed before. Okay. Now this Q1, the amount of charge flowing through this one, that is Q1 is equal to C1 into V. C1 is the capacitance of the first capacitor. Similarly, this Q2 is equal to C2 into V. V is constant as the amount of potential difference is same everywhere. Similarly, Qn is equal to Cn into V. Okay. Now we have to put in here. As you know, the net charge, that is Q, is equal to Q1 plus Q2 plus Q3 plus Q3, Q1 plus Q2 plus Q3 plus dash plus Qn. So putting here Q, that is C into V is equal to Q1, that is C1 into V plus C2 into V plus C3 into V plus dash plus Cn into V. Okay. Now taking common V from all these, so it becomes C1 plus C2 plus C3 plus dash plus Cn. Okay, this is equal to C into V. Now cancelling V from both sides, so C is equal to C1 plus C2 plus C3 plus dash plus Cn. See, here we have seen the capacitor on a parallel connection and we found out the net capacitance of these connection or the parallel connection is equal to C1 plus C2 plus C3 plus C4. That means the net capacitance of the capacitors when they are in parallel connection is equal to sum total of the capacitance of all the capacitors. That means we can write C is equal to sigma I is equal to 1 to n C I. Okay, this is the net capacitance of the capacitor. Remember, when the capacitors are in parallel connection, how we can say it is parallel? If one end of the all the capacitors are connected at one point and another end at another point, then this is called a parallel connection. Okay, so net capacity of the capacitance or net capacity of the capacitors C is equal to sum total of the capacitors of the capacitors. Okay, so C is equal to C1 plus C2 plus C3 plus C4 plus dash Cn. Okay, this is all about your capacitors in parallel connection. Hello. Now we will go to capacitors in series connection. Okay, first parallel connection, then series. I will discuss about the capacitors in series connection. Okay, I have taken here few capacitors. This is C1, this is C2, this is C3. Let this is C3, another one. This is C3. Okay, so similarly up to Cn. Here there are n number of capacitors connected in series. How we can say these are in series? If one end of the one capacitor is connected to another end, that means negative plate of one capacitor is connected to the positive end of another capacitor and negative end of one capacitor is connected to the positive end of another capacitor. That means one end of one capacitor is connected with other end of the another capacitor. In a series, we are looking here, one plate is left and here one plate is left. It is connected to the earth. Okay, this is earth. Now the potential is V and the amount of charge flowing through it is Q as before. Okay, as we know that V is equal to Q by C from before equation. Hello, we are taking here the potential. That means here V is equal to, that means net potential is equal to V1 plus V2 plus V3 plus dash plus Vn. Okay, as we know here the capacitance is C1, C2, C3 and Cn. There are n number of capacitors connected. Here the potential difference across the first capacitor is V1, let second capacitor is V2, let third capacitor V3 and similarly the last capacitor is Vn. Okay, so net capacitance, that is V is equal to V1 plus V2 plus V3 plus Vn. Okay, now we will go here the charge. That means V is equal to for first one, V1 is equal to Q by first charge Q by C1. Okay, okay, V2 is equal to, here the charge we have taken, the charge is flowing, similar charge are going through this one, so I have taken Q. Okay, V2 is equal to Q by C2, and third, that is V3 is equal to Q by C3, and similarly last one, let Vn is equal to Q by Cn. Okay, in first capacitor the potential difference, that is V1 is equal to Q by C1, V2 is equal to Q by C2, V3 is equal to Q by C3, similarly Vn is equal to Q by Cn. Now if we are taking this one here, as you know V is equal to Q by C. So putting this value here in equation, this equation, so it becomes Q by C. As you are taking here series connection, we can take this as C as CS for series is equal to V1 Q by C1 plus Q by C2 plus Q by C3 plus dash plus Q by Cn. Okay, now taking Q common from all these, 1 by C1, 1 by C2 plus dash plus 1 by Cn. Okay, this is equal to Q by Cs. Here cancel Q on both sides, it becomes 1 by Cs is equal to 1 by C1 plus 1 by C2 plus dash plus 1 by Cn. Okay, so we have seen that when the capacitors are connected in series, the reciprocal of the capacitance of total capacitance, net capacitance, is equal to the sum of the reciprocal of all the capacitors. That means we can write 1 by Cs is equal to sigma I is equal to 1 to n 1 by Ci. Okay, this is called your capacitors in series. Series means in one line. That means if we are considering about capacitors, that means the positive end of one capacitor is connected to negative end another, positive end another capacitor connected to negative end of next capacitor. Then only we can say it is connected in series. Okay, in series connection we found out 1 by C. That means the net capacitors, that is 1 by C, is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus there is 1 by Cn. This is all about your capacitors in series and capacitors in parallel connection. Okay, go through this one. After this class we will go to the resistance in series and parallel connection. Okay, thank you. Okay, now I am telling you, the friends, those who have not subscribed my channel, go to JAGDEV Sir Physics. I am writing here JAGDEV, JAGDEV Sir Physics, PHYSICS, Physics and Mathematics, MATHEMATICS, Mathematics classes. Okay, first you go to this channel, see my video. If you feel it is better for you, then subscribe with this one. Then you will find all the videos I am uploading one after another. It will help you in examination, in competitive examination and other examination. After completing these courses, I will go to teach about your engineering, mathematics and about your medical NEET, science and